At some point, every YouTuber's like, oh, sorry, I haven't posted a video in a while. And I never wanted to be that guy. Yet here I am saying, I'm sorry I haven't posted a video in a while. Some of you asked me where I've gone. And the thing is, I haven't actually gone anywhere. I've just been really busy. I mean, for one thing, I made that. But I made a bunch of other stuff too. For the first 4.5 months of 2020, I was building the Rancher Academy. It's Rancher's free online training destination that we just launched 3 weeks ago with the Certified Rancher Operator Level 1 course. This is a comprehensive 5-week training program that covers all of the things that everyone needs to know to install Rancher and use it to deploy and manage Kubernetes clusters. The course ends with a test and a certification from Rancher that says that you know what you're doing with Rancher in a production environment. This literally took my days, my nights, my weekends, because I wanted to build something that was more than just a bunch of YouTube videos. The response has been amazing. We had more than 2,000 students enroll in the first week, and that number's been growing by around 300 students every single day. By the 10th day, we'd issued more than 250 certificates. If you want to know more about it, you can head over to academy.rancher.com and sign up. It's totally free. So if you use Rancher, there's really no reason not to go and get the certification. The downside to being sucked into a project like that is that it's at the expense of every other thing, like this YouTube channel. I miss interacting with all of you, making content, finding ways to take complexity and turn it into something fun. So I decided to jump back in with a mega series that goes through upgrading the Kubernetes environment in my house. It's old, it's a little bit crufty, and it's got more than a few band-aids on it. I wouldn't go so far as to call it a monster that oozes unknown substances, but it's definitely taped up in a way where I can't really do anything with it except rebuild it. So that's what we're gonna do. I've been recording my progress along the way, and this is the first part where we're gonna install Rancher into a new K3s cluster, then we're gonna import another K3s cluster, and then we'll deploy Vault into it. My Vault and AWS integration is one of the subjects that people have asked me to make a video about most often, and today we're gonna do it. Along the way, we'll do some cool stuff with Proxmox, iSCSI, and LVM, and although everything doesn't go perfectly throughout the video, we get there in the end. So buckle up, and let's get started. I've done a bunch of stuff wrong here. Not necessarily wrong, I mean, not recommended. It's inherited from the early days of Rancher 2 and not having a lot of infrastructure. So now we're on Rancher 2.4, I have more infrastructure, and I desperately need to clean this up. So what I have here is a local RKE cluster that I installed Rancher into way back in the day. I then proceeded to use it for actual workloads, which is not recommended. Now, I mean, this is running in my house, so what are you gonna do? It's not like it's gonna blow up, but it mixes the resources needed by Rancher to manage the cluster with the cluster actually doing things. And fast forward to today, where we have, well, Rancher 2.4 for one, but where I have more infrastructure in my house that I can deploy stuff into, and where we have K3s, and I'm going to, well, I sat down today and I had this dilemma where I could either upgrade this, and as you see, it's running Rancher 2.2.4, it's running Kubernetes 1.13, and most of the stuff inside of it is also really old. So I could upgrade this kludgy Frankenstein beast, or I could start over. There's some problem with starting over in that there are things that I run inside of here that are gonna be a pain to move. Not all of them. I've got MQTT, I've got my Node-RED environment. Anything that you see that has 0 pods running means that it's just shut down. So Plex is here, that's important. Syncthing's important. Down here though, we've got some kind of really important things like Vault. I use Vault for dynamically generating temporary AWS tokens, and I use it as the certificate authority for a wildcard cert that I run for everything here in my house. There's basically 0 chance that I can upgrade that. It's running a super old version. It was not installed with Helm. Console also was not installed with Helm. So I'm probably gonna have to redo that from scratch and whatever. That's just the way that it is. Outside of that, the Unify controller I can move. That's for my ubiquity access points. And everything else here is not really all that important. So my plan is to shut down a bunch of machines that I'm not using, virtual machines over here in my Proxmox environment, shut down a bunch of stuff that I'm not using right now to free up some CPU and RAM. And then install K3s, install Rancher into that, install a second K3s cluster, and take the 4-node RKE cluster that I'm running right now and shut nodes down so that I have everything running on just one node, and then move things over. It's currently 3:30 in the afternoon, and I'm pretty sure that I can get all of this done before 6. Well, maybe not all of it, but a lot of it. So let's see what happens. First order of business, I need to come up with some space in which I can install K3s. So if we look at here, I'm running virtual machines and LXC containers. Depending on what the workload is, I either have a VM for it, I have it running inside of Kubernetes on one of the Rancher VMs, or I have it running directly as an LXC container. I know that my Elasticsearch environment existed for storing data from ntop-ng back when I was doing a lot of aggressive caching and needed to know which machines in my house were using all of the resources, and that's not working right now. So we'll just shut these two down right out of the gate. ntop-ng we can also shut down. Graphite, that's important. That tracks all of my solar and household usage stuff. Zabbix, not doing anything. We can shut him down temporarily. Null is my Pi hole. That's important. Transmission, at the moment, we can shut that down. Net data, we need to keep that one up. Now, down here under virtual machines, black hole, that's the firewall. There's the Rancher boxes. Gal is my Home Assistant environment. Training S, that's my weekly training system. Nexus is important. That's my local caching pull-through proxy for Docker containers so that I don't have to pull stuff on all kinds of machines. So we need that up. Suite CRM, we don't need that for the moment. We can shut that down as well. How many people do you know that run a CRM utility in their house? Me. All right, this should be enough to get me started on PVE03 with a K3s node into which I can install Rancher. Because this is in my house, I'm not going with HA K3s. I'm totally fine just running it on a single node K3s box. I have a template out here. Looks like 2 CPUs, 4 gigs of RAM, 20 gig boot drive. I'm pretty sure this is running Ubuntu 18. So we'll just clone that. HA for me means a couple of different things. In this environment, I'm okay with the Rancher server not being available for some period of time. I'm less okay with the Rancher server blowing up and nuking all of its data. So to handle that, I'll just make backups of the SQLite database, or I might even make complete snapshots of the VM when I need to. That'll protect me from disaster in the sense of an actual failure of the environment. As far as availability, all of this is backed by shared iSCSI storage. So, well, and the iSCSI is actually a single point of failure because I only have a single Synology NAS, but it's got redundant drives and stuff like that. And it's my house. So what if it goes down? But I could take down one of the Proxmox nodes and it will restart services on other systems because all of them can mount volumes from the iSCSI backend. All right, R01 exists. If we look at your storage, you are on local LVM. We want to move that. Move disk. And we're going to move you to NAS02 LVM. Wow, you don't seem to think you have very much space left over there. Today is about shaving yaks. So let's go over to the NAS. And let's see if we can increase the size of our iSCSI backend. We can't increase the available storage without shutting down everything that's connected to it, which shuts down the entire environment, including firewalls and everything that uses it. Because I have to shut down the Proxmox boxes. But what we can do is create a new one. We're going to create a new LUN. And we're going to allocate another 1,000 terabytes. Thin provisioning, yes. With space reclamation, advanced LUN features, yes. We'll say next, yes. We'll create a new iSCSI target. We'll call this PVE storage 02. PVE storage 02. Say next and apply. And now we have a new target available. So if we come back over here, come out here to storage, we have NAS02 iSCSI. That's PVE storage. We're going to add new iSCSI ID NAS02. Target PVE storage 02. Nodes all enable yes. Use LUNs directly. Sure, sounds good. Add. Oh, that's interesting. Sorry to interrupt. This video spans several hours of work, so the only way that it makes sense for you to watch it is if I take the parts where it goes sideways and replace them with short summaries like this. iSCSI didn't initialize the way that I expected, and I ended up rebooting everything. It would only attach to one node, and that's when I realized that I hadn't gone back in and checked a very important box. It's a box that says, allow multiple nodes to attach to this target. And once I did that, everything came up. But there's another thing that I want to explain here that's a great feature of Proxmox, and that's using iSCSI volumes as physical volumes for LVM. What I'm creating here, which I couldn't show in anything that remotely resembles a timely fashion, is that once I have the second LUN attached to all of the Proxmox nodes, I can add it as a PV, and then I can extend the volume group to include it. Proxmox creates LVs for VMs and containers, and that way I don't have to have a zillion iSCSI targets set up for all the VMs and containers. I can resize disks and I can do all of the things that LVM allows while still using an iSCSI backend. It's pretty cool, right? The only thing is that you can't do it from the UI. So if you find yourself in this situation, just create a new iSCSI storage volume in Proxmox, and then from one of the nodes, use pvadd and vgextend to join it to the volume group. Proxmox will pick it up, and the size of your volume group will reflect the new storage. Just make sure that all of your targets are on the same backend. Don't split this up between different iSCSI target nodes, because if one of them goes offline, you're pretty much guaranteed to end up with data corruption. Nice. Nice, nice, nice. That right there. We just gave ourselves an extra terabyte of space. So we're in business. So we're now migrating from local disk on whatever host this was, PV04, to shared iSCSI storage, which will allow this host to be fired up on any of the Proxmox nodes, because although iSCSI itself isn't designed for multipathing with simultaneous access to the same file, Proxmox will handle that. It'll make sure that the virtual machine's disk is only attached to the virtual machine that's running on one of the nodes at a time. It'll shut it down before it brings it up anywhere else. So there's zero chance of corruption. Anyway, it's going to take it a few minutes here to move itself. And by a few minutes, I mean like a half an hour. While the Rancher node's disk is moving to its new home, I do a bunch of other stuff, like configure DNS for the new nodes, set them up in Ansible, launch the first workload cluster node from the template, and then I grow its disk from 20 gigs to 50 gigs before I clone it twice more.
That's major bullshit.
Editing a physical disk when it's virtual is surprisingly simple. You just redefine the borders of the partition and write it out. the data stays where it is. So as long as you get the starting sector right, and as long as you're not overwriting any partition that follows it, you'll be fine. This works best when you have a single partition that runs to the end of the disk. Just delete it and then recreate it with the same start and using all of the available sectors. How many of you remember making different partitions for root, var, user, opt, SRV, and others? Man, when it became normal to just make one big partition for everything, I thought it was heresy. And actually, if you don't know the origin of the word heresy, go look it up. It doesn't actually mean what you probably think it means. So I considered including the K3S install for R01, but it's really easy. It's just ketchup install --IP equals IP --user equals Ubuntu. A few seconds later, and we have a K3S node and a fresh kube config sitting in our local directory. Let's add rancher stable. Already there. Very nice, very nice. Create the cattle system namespace. Done. We're gonna go with self-signed certificates because I'm in my house and my ISP like quintuple nats my traffic and there's no way I can get anything back in. Okay, cert manager is installing. We'll let that do its thing. And initially I will put that in DNS. Let's delete that. It points to the load balancer right now, and it goes to the primary rancher server. If I had multiple nodes, then I would put it at the load balancer and point it to multiple nodes. But since I only have one node right now, I will simply point it directly at R01 by adding it as an alias. All right, rancher is rolling out. Let's go bring up our K3S nodes. It's 520. Definitely not going to get everything migrated by 6, but we'll have a rancher server environment up. Yes, we will. When K01 was done, I cloned it twice more to K02 and K03, and then I ran Ansible against all of the nodes to get them all dressed up and ready for school. This is taking way longer than it should, because I'm totally crushing the I/O on these nodes as I clone and move disks to the iSCSI backend. Crush, crush. Oops. Nice. Okay, I mean, there you go. That was fast. Rancher 2.4.3. We got our local cluster. Local cluster we do not deploy workloads into. These are going to be in an updating state. They'll check back now that we've set the server URL. They'll poll periodically, and once the backup timers expire, they'll change to active. so easy, it's almost boring. And I say that jokingly, but it's true. It's almost boring. Like all of the stuff that's going on here has nothing to do with Rancher. The stuff that's taking time is everything else. It's iSCSI volume provisioning and host cloning and Ansible provisioning and stuff that you can shorten the duration of by using tools like Ansible or Terraform or as part of the provisioning process. It's 545. Not going to have everything migrated by 6. I will, however, have K3S cluster and a new Rancher server. And then I'll eat dinner. And after dinner, I'll come back and provision Vault. Vault is the main thing that I need. I need Vault for the Twitch AWS live stream that I'm going on so that I can provision short-term IAM credentials, just in case one of them pops up on a screen or something like that. You know, it'll have expired already. While waiting for the nodes to provision, I went back to Proxmox and I discovered something that might develop into a product. All of my K3S nodes are stacked up on PVE04, which doesn't really matter. I mean, they'll restart quickly if that node goes down, but I want them a little bit less stacked up. So I'm going to take K03 and put it in the group to prefer node 1. And there it goes with the migration. And I'll take 02 and set it to prefer node 3. And I'll set 01 to prefer node 4. So that just means that if all the nodes are up, they'll be spread out. If they restart, they'll restart on that node. And if that node's not available, it'll restart somewhere else. Want some? What this also meant is that because those groups are configured to do failback, as soon as I put the nodes into a group, they migrated from PVE04 to their target node. This is the sort of thing that could cause a service interruption, but it didn't. The entire point of this whole iSCSI LVM exercise is that we're set up for shared storage and live migration. And this was just a demonstration of that functionality. All right, how's our Ansible stuff doing? Oh. Not sure what's wrong with K03, but we'll run him a third time. And while that's going on, we'll come back over here and we'll start our K3S installation. I decided to go with an HA install, which K3S handles with an external data store or an internal implementation of DQLite. I don't feel like adding another layer of hosts to this with a MySQL cluster, so I'm going to use DQLite. You can install this by passing --cluster to catch up when you install the first node, and then passing --server to catch up join when you install the other nodes. It's completely possible to do HA with just 2 K3S nodes if you're using an external data store like MySQL. But if you're using DQLite, you still need 3 nodes for quorum. There we go. Wife just called for dinner. I have failed. 6 o'clock. All right, we'll come back after dinner and we'll finish this. Back now. Post-dinner, different shirt. I don't know why. I was doing a live stream with my wife and my other shirt. The mic wouldn't sit right, so I changed shirts. Anyway, whatever. This is basically done. Yeah, it's basically done. K03 spat back a weird systemd error, but by the time I got back to it and looked at it, it was fine. So I don't know what it was complaining about, but we're up, we're good. They're all talking to each other. And so we're ready to bring this cluster into Rancher. In Rancher 2.4, when you import a K3s cluster, it treats it a little bit differently from another imported cluster. It actually detects that it's K3s and it flips some switches that allow you to manage the K3s cluster the same way that you could manage an RKE cluster. So you'll be able to do upgrades and do a whole bunch of other stuff with it. So let's do that now, and we'll see what it looks like. I always go to the docs whenever I'm doing any of this stuff, no matter how many times I've done it, except maybe like launching the Docker container version of Rancher, because I know the command back and front. But I always go to the docs to make sure that I have a checklist of things that I'm following as I'm doing any of these things. So I'm actually in the K3s docs. Let's jump back over to the Rancher docs. Imported K3s clusters, additional features. All right, nothing special for importing it. And we'll use the second one because we don't have a trusted certificate. I forgot. I forgot to configure them to pull from the cache, so they're gonna all pull their stuff across the internet. That's gonna take forever. Shoot. As I said earlier, I run a Nexus artifact repository that acts as a pull-through cache for all container images that come from any external repo. Because of how K3s works at install, it's not possible to configure this before installing. I have to install and then copy config.toml to config.toml.tmpl, then edit config.toml.tmpl to add the values, and then restart K3s. When K3s restarts, it copies config.toml.tmpl to config.toml, and voila, we pull through the cache. All right, we're actually going to go and just do that right now. Because right now all they're doing is just pulling the container image, so restarting them, I mean, it's painful for them, but they'll get over it. And they did. After restarting K3s with the new cache config, whatever deploys were happening restarted, and they pulled from the Nexus repo. This is one of my favorite things about cloud computing, the whole idea of rip and replace. For something to be in the middle of an action, have the floor ripped out from under it, restart, pick up a new configuration, and continue as though nothing happened, it's a thing of beauty. And there we go. Sweet. We got the local cluster, which is Rancher, and we got the home cluster. Okay, so the next thing that we want to do is get our Vault config up and running. At this point, the memory card on the camera that was recording my face ran out. So in the next couple of minutes, there's going to be spots that just have me doing voiceovers, or maybe I'll use a sock puppet or something. Sorry. So what I want from Vault. Vault, you can do all kinds of things with it, but what I need from it more than anything else is the ability to dynamically generate AWS IAM credentials. I can set up Vault with a super user key, and then I can request that it use that key to generate temporary credentials. Those credentials can expire in an hour, in 2 days, and whatever. I use those temporary credentials in my videos, and they tend to expire a few hours later. So by the time the video comes out, those keys are gone. And that makes it so I don't have to worry about keys leaking, about trying to remember where I used it so that I can block the video out or whatever. It's just, it doesn't matter. Remember earlier when I said we were going to be shaving some yaks? Well, it hasn't ended. I'm not installing Vault in HA. For a real production environment, you should install it in HA with console, but we're on a budget. Instead, I'm installing it in standalone, but it still needs some sort of backing storage.
I'll use NFS for this since it's already set up, and it's a step down from iSCSI in severity. That means that I have to enable the Helm stable repo and install the NFS client provisioner. I also have to install NFS common on the K3s nodes, which in turn requires that I add some configuration to Ansible so that that change isn't lost. I enable the repo at the global level, and then wait a minute or so while it refreshes. Then I can install the NFS client provisioner, passing it the location of the NFS server and the volume path within which it will create NFS PVs. Now that I've got a storage class for provisioning NFS, I'll add the hashicorp repo to the catalog at the cluster scope, wait for it to refresh, and then install Vault. I only need to tell Vault the name of the storage class to use for the data and audit storage, along with the volume sizes for each of them.
And now it gets funky. Ordinarily, you initialize Vault with a number of unsealed keys. This is a Vault that's running in my house that I'm the only one who's ever going to access. So I'm going to initialize it with just a single unsealed key.
When the pod comes up, the readiness check runs Vault status inside the container, and this will return an exit code of 2 if the Vault is sealed or if it hasn't been initialized. Don't let that bother you. Just shell into the container and run Vault operator init to create the Vault.
You only have to initialize the Vault once, but anytime you restart the pod or if you've sealed the Vault, you'll need to unseal it before you can access it. All right, Vault is initialized, Vault is unsealed. Now let's hook this up for AWS. Vault does not open a listener outside of the cluster. So if you want to communicate with it, you have to do port forwarding, and then you have to set the Vault address variable to localhost 8200. That shows me that I'm connected to it. Hooray! With that, we can now point a browser at localhost 8200 and get the Vault UI.
Okay, now that we're logged into Vault, we create a new secrets engine. I'll name it AWS Rancher, and I'll adjust the default and max lease TTLs to numbers that better suit my use case. Then, under Configuration, I'll click Configure on the right and set my access key and secret key, and then click Save.
I don't know why I have to set the lease again in this section, or if it's even necessary, but it didn't pick up the defaults in the secret engine parameters, and 30 seconds is just too low. So we'll set it to the same values for default and max. Shh, I'm trying to watch the film.
The next step is to create a role. Give it a name, set the credential type to IAMUser, and then start plugging in Policy ARNs that map to the permissions you want this role to have.
I'm creating an admin role. You can, and you probably should, have as many roles as necessary to follow the rule of least privilege. For me, my use case, where I generate keys that might deploy resources all over AWS, I need an admin role that gives me access to EC2, RDS, S3, Route 53, VPC, IAM, CloudFormation, EKS, and a couple others. I'll put them all in the video description. These are default AWS IAM roles, and you could also just attach a policy document in the space down below. Okay. We can generate credentials here from the UI, or we can generate them from the CLI. Either one works. These are going to be good for the next 4 hours. So I can use these, use them in a video, use them in whatever, use them in a config, and I don't have to worry about them except for 4 hours. Unless I renew them, they'll be gone. That's the main thing I needed to get done tonight. It took a lot longer than I expected it to, although by the time you see this video, you won't know that because I'll chop it up into little small bits to make it digestible. But it's now 11:30 and I'm ready to go to bed. I'll see you next time. Let's eat popcorn together.